Hi there, my name is Dimitris Charalambidis, and in this short video, I'll give you an example on how we work when we are given a function f, we are given a point x0, a point with x-coordinate x0 that lies on the graph of this function f, and we are simply asked to find the equation of the tangent at the graph of f at this x value. Let's see quickly an example. Let f of x is x squared plus 2x plus 3 and x0 is 1. Find the equation of tangent to the graph of f at x0. Okay, at first, we will always begin, we always start with the knowledge that the equation of tangent we are looking for is of the form y minus y0 equals y minus f of x0 equals f prime of x0 times x minus x0. On this equation, there are three things that should be found by us. These are the value of f of x0, the value of f prime of x0, and the value of x0 itself. Let's start with the easiest one. This should be the value of x0, because in the majority of the exercises, it will simply be given from the beginning. So x0 equals 1. This will enable us to substitute x0 by 1 in the above equation. So instead of having this y minus f of x0 equals and so on, we will rewrite it as y minus f of 1 equals f prime of 1 times x minus 1. So right now, I have reduced the unknowns into simply 2. I still need to find the value of f of 1 and the value of f prime of 1. Let me do the f of 1 first. F of 1 means go to f of x and instead of x, put 1 instead of x. So this means that since f of x is x squared plus 2x plus 3, then the f of 1 would be 1 squared plus 2 times 1 plus 3, which is equal to 6. So I can rewrite the equation of tangent I am looking for into a new equivalent form. Instead of f of 1, I have already found it to be equal to 6, so I should rewrite it as such. Y minus 6 equals f prime of 1 times x minus 1. I now need to find the last missing piece, which is f prime of 1. F prime of 1 in general means go to f prime of x and put 1 for x. But the thing here is that we don't know the value of f prime of x. We still don't know the derivative of f. Okay, we'll calculate it. F derivative of x is the derivative of x squared plus 2x plus 3, which means the derivative of x squared plus the derivative of 2x plus the derivative of 3, which means 2x plus 2 plus 0. So f derivative of 1 should be 2 times 1 plus 2, which is equal to 4. Finally, I'm now ready to plug in the last piece, And the expression I had before, y minus 6 equals f derivative of 1 times x minus 1, can now be rewritten into its final form. Instead of f derivative of 1, I'll substitute it by 4. So it should be 4 times x minus 1. This is exactly the equation of tangent I was looking for. We can either leave it like that, it would still be acceptable because it's actually the point slope form of a line, or we could do some simple operations to bring it into a slope intercept form instead. These operations would include distributions first. I multiply 4 by both x and by -1, so I get 4x minus 4. And then I isolate y on one side and bring everything else carefully on the other side. So y should be 4x plus 2. Both of them, again, are acceptable. So once again, to review what we just did, we will be given a function f of x, a point x0, and we will be asked to calculate the equation of tangent of f at that x value. We always begin by writing the general form. Every equation of tangent should look like that. Y minus f of x0 equals f prime of x0 times x minus x0. From the beginning, you should keep in mind that we need three things: to find the value of x0, to find the value of f of x0, and to find the value of f prime of x0, the derivative of f at x0. Starting from the easiest to the hardest, we begin by x0. x0 will always be given in our exercises. So x0 equals 1. I substitute that already. Then the next easier part is finding f of x0. And why is that? Because I already have the value of f of x, and finding f of something simply means go to the function f and instead of x, put that something. So f of 1, in that case, would have been going to f and put 1 instead of x. Once we calculate that, we substitute it as well. And finally, we need the derivative of f at that point. This demands two actions from us. Firstly, calculate the derivative of f, applying the derivative rules that we know. And then on that function, on the derivative of f function, substitute the value of x0 at x. Once you do that, and once you calculate the f derivative of x0, you are ready to substitute it into the equation of tangent and finalize your result. That would be all. For any question on what we just saw, you are more than welcome to leave your comment below the video. As always, thank you for watching and thank you for your time.